Hello guys! Welcome sa ating z-knowledgeTV.
Okay, so in this video, we will discuss the concept of embedded systems.
So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started.
So, here are the different topics that we will discuss for this video. So, first is the introduction, next the definition, the main components, examples and applications, computer versus embedded system, block structure diagram, architecture, classification of embedded systems, EDLC, advantages and disadvantages, relevant tools, and also the standards and engineering constraints. So now, let's proceed in introduction. So let's define first what is embedded. So embedded means including something with anything for a reason. Or simply, we can say something which is integrated or attached to another thing. While the systems defined as a set of interrelated parts or components which are designed or developed to perform common tasks or to do some specific work for which it has been created. So now, in these two definitions, different definitions of embedded system was defined. Okay, so first is according to Steve Heath. So an embedded system is a microprocessor-based system that is built to control a function or range of functions and is not designed to be programmed by the end user in the same way that a PC is. While for according to Raj Kamal, an embedded system is a system that has embedded software and computer hardware, which makes it is a system dedicated for an applications or specific part of an applications or product or a part of a larger system. And according to Wayne Wolf, an embedded system is any device that includes a programmable computer but not itself intended to be a general purpose computer. So, based on the different definitions, so we can based on different definitions, we could say that an embedded system consists of a combination of hardware and software that are developed to carry out a certain functions. So it can be said as a dedicated computer system has been developed for some particular reason. So, but it is not our traditional computer system or general purpose computers. These are the embedded systems that may work independently, okay, or attached to a larger system to work on a few specific functions. So, these embedded systems can work without human intervention or with little human intervention. Next, so let's proceed in the main components of embedded system. So there are three main components. So the first one is the hardware. The second one is the application software or simply a software. And last is the RTOS or the real-time operating system. Or we can say that it is a firmware. So these are the three components of embedded system. Now, we have different parts of the hardware components. So this one is the block diagram. So in hardware components, we have the power supply, the set and insulator circuits, And also we have the input devices, interfacing driver circuits, and output side, which is the output interfacing driver circuits. And the internal part is the processor, timers, interrupt controller, program memory, and data memory. And we have also the serial communication ports and the parallel ports. And the other one is the system application specific circuits. So we have the different examples and applications of the embedded system. So for the examples, so we have a digital watches, washing machine, toys, televisions, digital phones, laser printer, cameras, industrial machines, electronic calculators, automobiles, medical equipment. So we have also the applications in the real world. So the different applications are the home appliances, transportation, healthcare, business sector and offices, defense sector, aerospace, and also the agricultural sector. Now, let's differentiate the computer and the embedded system. So for the computer, we have the input devices and also the output devices. Also the central processing unit, or what you call CPU. And also the main memory, which is the RAM, and the secondary or the backing storage, which is the disk. And for the embedded system, so we have the user interface, the memories, processor, inputs, outputs, and the power supply. So let's deeper differentiate the difference between the computer and the embedded system. So first is for the category of description. So computer is a combination of hardware and software resources which integrate together and provides various functionalities to the user. While the embedded system or device is a part of an integrated system that an embedded is formed as a combination of computer hardware and software for a specific function and which can operate without human interaction or with a little human interaction. Next, for the human interaction category, for the computer, a computer needs human interaction to perform tasks, while for the embedded device, it does not need human interaction to perform tasks. For the types based on architecture, analog computer, digital computer, hybrid computer, Harvard architecture, von Neumann architecture, reduced instruction set computer, is part of the architectural for the computer. While for the embedded system, it has the small scale embedded system, medium scale embedded systems, sophisticated or complex embedded system. Next, for the parts of the computer, it has only two parts, which is the hardware and software. While for the embedded system, it has three parts. It includes the firmware. Next, for the task, for the computer, it can perform many tasks. While for the embedded system, it performs limited tasks. Next, for the cost to user, the user has to pay more for a computer. While for the embedded system, the user incurs lesser cost for an embedded system. Next, for the peripherals, computers have peripherals such as a keyboard and mouse, display printer, hard disk drives, floppy disk drives, optical disk drives, and etc. While for the embedded devices, it has peripherals such as serial communication interfaces, or what you call the SCI, synchronous serial communication interface, universal serial bus, or what you call USB, then multimedia cards, or wherein we have the SD cards and compact flash and etc. And for the purpose of the computer, computer can be reprogrammed for a new purpose. While for the embedded devices, it made only for a specific set of purposes. Next, for the power consumption, A computer needs more operational power than embedded devices. While for the embedded devices, it needs lesser operational power than a computer. For the complexity, computers are more complex devices than embedded devices. While for the embedded devices, it has less complex devices than computers. The next, for the need of another device, computers may be installed in other devices but are self-sufficient to exist. While for the embedded devices, it only exists inside other systems. For the usage difficulty, computers are more difficult when used compared to an embedded system. While for the embedded, it has the advantage wherein it is easier to use than computers. For the user interfaces, it requires more user interface than embedded devices. And for the embedded devices, it requires lesser to no user interface than computers. Next, for the time specificity, computers are not time specific. They may need to perform tasks which are not time bound and take days to perform as well. While for the embedded devices, it has the time specific. The tasks assigned to them need to be performed within a specific time frame. For the size, computers are usually bigger in size, with larger hardware and input-output devices attached to it. While for the embedded devices, it has a smaller in size than computers with limited hardware. So, computer developed in 1833 AD, while for the embedded system, it was developed in 1965 AD. And the computer was developed by Charles Babbage, while the embedded system was developed by Charles Stark Draper. Next, for the memory requirements, computers have larger memory requirement due to a lot of storage of data, while for the embedded devices, it needs lesser memory. Next, let's proceed on the block structure diagram. So this is the block structure diagram of the embedded system. So the embedded system composed of the microcontroller, wherein it has a microprocessor, a memories, and also the bus, the address, the data control, wherein it has also the input ports, output ports, and also the external circuits. And we can also see these input signal and output signal going and out, going to physical devices. So here are the architecture. So typical embedded system mainly has two parts. It was the embedded hardware and the embedded software. So embedded hardwares are based around the microprocessors and microcontrollers, and also include the what you call the memory, the bus, the input, output, the controller, whereas embedded software includes embedded operating systems. So different applications and device drivers. And also basically, these two types of architecture, which is the hardware architecture and the von Neumann architecture, are used in embedded system. Okay, so let's proceed for the another deeper architecture of the embedded system. So first is for the input side, wherein we have the sensor. And for the sensor, it was going to analog to digital converter, or it may going to the memory. Next, once the data processed in the AD converter, it may going to processor and ASIC, or what you call the application specific integrated circuit, or maybe it will loop another to again to AD converter, then proceed to the memory. And also we can say that the data may back and forth to processor and ASIC or to memory. Then it was going to DA converter, or the digital analog converter. Then Afterwards, it will proceed now to your actuator or your input part. Next, we have different classifications of embedded systems. So, embedded systems are classified based on these two factors, which is the performance and functional requirements, and also the performance of microcontrollers. So, based on performance and functional requirements, it has divided into 4 types as follows. So, first is the real-time embedded systems. So, it means that it is a strictly time specific, which means this embedded system provides output in a particular defined time interval, since it was called real time. Okay, so this type of embedded systems provide quick response in critical situations, which gives most priority to time-based task performance and generation of output. So that's why real-time embedded systems are used in defense sector. Maybe it will use in medical and healthcare sector, and some other industrial applications where output in the right time is given more importance. Okay, so there are two types of real-time embedded system. The first one is the soft real-time embedded system. So in these types of embedded systems, time or deadline is not so strictly followed since it is soft. Okay, so if the deadline of the task is passed, means the system didn't give result in the defined time, and it is still result or output is accepted. While the other type is the hard real-time embedded systems. In these types of embedded systems, time and deadline of tasks is strictly followed since it is called the hard real-time embedded system. So we ask must be completed in between time frame or defined time interval, or otherwise result or output may not be accepted. So we have different examples of the real-time embedded systems, which is the traffic control system, military usage in defense sector, and medical usage in health sector. So another one is the standalone embedded systems. Are independent systems which can work by themselves. They don't depend on a host system. So meaning, it takes input in digital or analog form and provides the output. So we have the examples, which is the MP3 players, microwave ovens, and the calculator. Okay, for the network embedded systems, are connected to a network which may be wired or wireless to provide output the attached device. So meaning, they communicate with the embedded web server through network. So we have examples, which is the home security systems, ATM machine, and the card swipe machine. And the last one is the mobile embedded system. Are small and easy to use and requires less resources. So meaning, they are the most preferred embedded systems. In portability point of view, mobile embedded systems are also best. So we have different examples. We have the MP3 players, mobile phones, and the digital camera. Now, let's proceed in the performance of microcontroller. So we have 3 different types. So first is the small scale embedded system. So small scale embedded systems are designed using an 8-bit or 16-bit microcontroller. They can be powered by a battery. So the processor uses very less or limited resources of memory and processing speed. So we have different examples. We have the temperature measurement embedded system, washing machine, robotic arm controller, digital camera, and also the home security system. So in this home security system, it is very famous. wherein a microcontroller in the system is for controlling all the necessary operations. So the sensors give data, and if something wrong happens, then safety alarms activate and start beeping. So other the examples in home security systems is the gas sensor, motion sensors, smoke sensors, temperature sensors, IR sensors, and others. Next, the medium-scale embedded systems are designed using an 16-bit or 32-bit microcontroller. They are faster than that of small-scale embedded systems. Integration of hardware and software is complex in these systems. So Java, C, C++ are the programming languages are used to develop medium-scale embedded system. So different type of software tools like compiler, debugger, simulator, and others are used to develop this type of systems. So we have an examples, the routers for networking and the ATM or the automatic teller machine. The last one is the sophisticated or what you call the complex embedded systems are designed using multiple 32-bit or 64-bit microcontroller. These systems are developed to perform large-scale complex functions. These systems have high hardware and software complexities. So we use both hardware and software components to design final systems or hardware products in this sophisticated or complex embedded system. So we have an examples which is the smartphones and the multimedia systems. Now, let's proceed in EDLC. So EDLC means Embedded Product Development Life Cycle. So developing an embedded system or product mainly goes through these 7 steps. So first is the requirement analysis, then goes to examine, design, develop, test, deploy, and maintenance. So these 7 steps was used to develop an embedded systems. So now we have the different advantages and disadvantages of embedded systems. So first, let's proceed in advantages. So in advantages, we have small size and shape, wherein we can use it in small parts or small board. And also the enhanced real-time performance, easily customizable for a specific application, consumes less power. These systems are so scalable and reliable, and also performs specific tasks without error. While for the disadvantages, so high development costs, time-consuming design process, as it is application-specific, less market available, difficult to back up of embedded files, sometimes complex to develop, integration may be a problem, and troubleshooting may be a difficult, and also, since the troubleshooting is difficult, then the maintenance may be a problem. So we have different relevant tools for embedded system. First is the embedded languages. So we have C, programming language, the C++, and also the assembly. Next, for the microcontrollers, so we can use Atmega 328P and also at Tiny 84. For the in-circuit programmer or in-system programmer or in-circuit serial programmer, we can use different types wherein it is the Arduino, Picket2 starter kit, PIC microcontrollers, AVRs, and parallax propeller, and others. So we have the recent technologies that can use in-circuit programmer. Now, what are the standards and engineering constraints? So embedded systems are built for specific purposes and are optimized to meet different kind of constraints or limitations such as the following. First is the performance. Second one is the efficiency. The third one is the reliability. The fourth is the safety. Fifth is the security. Sixth is the usability. And last is the robustness. So meaning, since we have different limitations, so the design process therefore involves different optimization activities to further develop different embedded systems. Okay? So this is the end of the presentation. So thank you and God bless.